Do you really think this is a MakeX video? Well, I don't think so. What am I doing? I'm in a tree building a tree net, like a spider net before humans, like a human net. You say, why am I doing this? The better question is why not? This tree is called Abraham and it's in the backyard and I wanted to build a net. That's what I'm doing. And I have a backpack. And I have ropes and more ropes, harness, carabiners, a sender, belay, more ropes. I want to make more videos, but I can't right now, and this is why. I moved. I don't have a place to film, and this is not my garage. I just found it. I want to keep on filming because I feel like people are benefiting from some of these videos, and so I'll start cleaning up the garage and probably make it into my own workshop and start from there. And I also want to upload this before the 31st because I haven't been uploading for an entire year. So the fastest thing I could think of is making a Q&A video for MakeX. How to climb a tree.
Hey climbers, Chris here from Bartlett Arborist Supply. On a how to climb with the basics. Good to climb on hold and wait. Moving rope system, double rope system.
I think I got it. The first question is, what are some tips on improving competition performance? Having a checklist will always help. I know sometimes you feel like having a checklist is unnecessary, where you'll probably spend more time making the checklist than really using the checklist. But what we had in the past, one of them is before you go to the competition, and the other checklist is you use it before the competition. Every time before you go into the competition, you would go through an entire checklist, so make sure you have prepared your team and your robot for the competition. For example, some of the stuff we have for the competitions are fresh batteries, controller, check controller's connection, and also like check autonomous code for which side you want to be on. Definitely sometimes it do feels unnecessary and I don't really like to use it, but it helped me once at the competition. And ever since, I'm sticking with the checklist. So I make sure to check all the boxes before I go on the competition to make sure the robot is competition ready. Before any of this, I did a test run on the ground understanding all the rope behavior. After getting into the tree, I looked around to find 3 or more anchor points that I can set my main rope on. Then I started to clean up some of the axis branches that are growing at unwanted places. I started off with paracords as a guide rope going around all the anchor points. After that, I tied the paracord to the main 10.5mm static rope and pulled the paracord around all the anchor points. When building something like a MakeX robot or a telescopic arm, how long did you spend on planning, prototyping, buying materials, doing calculations, and others? Telescopic arm is definitely something harder to make for a MakeX competition. Some of the manufacture techniques are more like FRC. So for the mechanism, I did 3D design using SolidWorks. I have to manufacture the tubings, I have to source the materials, and then a lot of 3D printed parts. For the planning stage, it took around 2 days to complete, to gather all my thoughts, to get all the dimensions that's required. The further developments continue throughout the entire build stage because you kind of start to understand the mechanism when you start designing or building it. And basically you just keep on developing the robot throughout the building stage and you improve every time you make a change. For this project, it took around 2 weeks to get through the prototyping stage. And at the 1 week mark, you kind of already have a scope of what the entire robot would be like. And you could pretty much get most of the stuff at that point. Hopefully it will arrive within the 2 week mark and then you can actually interact with the materials, you could start measuring it, and then you can start building it. I believe it went through around 5 iterations for some of the parts to come to that video state. But the reason for this is because sometimes it's easier to just print the mechanism and then you visualize the problems and then you just fix it at that point. And sometimes it's just faster to reflect, redesign, and then rebuild. Go through the cycle for most of the parts. Hopefully you're able to manufacture it in-house and then that would just speed up the process a lot more. Overall, it took a month to build this mechanism. It would be faster if you had a team, so different people could take different sections of the mechanism and then you could like argue out the problems when you see them. Sometimes I would go through arguments mainly because if you are making all the decisions, it will most likely be a biased answer. So a lot of time in the past, me and Charlie would go into arguments and we would debate whether this mechanism is better than the other one or this one is probably going to be more efficient. And it definitely helped me, probably both of us, on improving the robot tactics and improving the techniques we're going to use. It definitely helped us on improving the tactics or the entire design of the robot or different components. I feel like if we didn't go through these heated talks, we wouldn't be able to try out all these different options and components. Because both of us is trying to prove each other's point and it kind of like drive us to build these different mechanisms and just to prove to each other that our ideas is better. And that kind of really helps if you have a longer build season and both of us are working on different components, and then after we go to the competition, we will reflect on the weaknesses of our own designs. And at the final competition, for example, like the international competitions, both of our mechanisms would be pretty similar. And I also want to add on to what I previously said. I wanted to incorporate a different type of method on building a MakeX robot. As we know, most of these parts in MakeX competitions are standardized. For example, the beams, the spacing between each hole. If teams have 3D printers at their workshop or their school, it definitely opens up a new field of building robots. You could have so much customized parts, and then you could tinker with different type of geometry for building the MakeX robots, and you could learn a 3D design software, understanding different type of material properties, and it'll definitely benefit you right now, and definitely in the future if you're in this field. And then after that, I tied 2 figure-8 knots on either end and used a rope reduction to pull both ends tight together. I know there's probably better ways to do it. I want to explore all the options before I weave another net on top of the trees. When you want to start a project, do you have a plan or do you just jump straight into it? Yes, definitely. First is finding a need, either from friends or colleagues or requested by the companies, or just something I personally believe what is beneficial for the viewers. Usually when I start a project, for example the telescopic arm that I made years ago, I will start to brainstorm the problem. And then I'll pretty much start proving my concept. It's either through SolidWorks or just prototyping in general. Next question is, are you in China? No. I changed up the design a little bit. Before it was just going all over the place, and I feel like having a pattern would be better. What I've noticed is that if you start from the center of the net, the net will be pulled in from the middle. The more weaving you do from the middle out, the center part kind of starts to sag, and you will kind of lose the tension. So I've started at the closest point I could get to, so this point and this point, and that will be my first rope. And I will start off my second rope here. And every time I do these zigzags, it will pull in and it'll make this one a lot tighter. And every layer I go in, it will kind of just tighten itself and it'll start to make the net a lot stronger. I don't know what I'm doing. I just learned this on YouTube, so just trying it out. This is my first net, so it's probably gonna have a lot of problems with it. And I wanna build it, see what it's like, how much it sags, how to improve it. And I'm gonna build another one up top. That'd be a lot cooler and we could take this down. I mean really me, because I'll be the only one coming up here, but no. First prototypes, pretty cool. This one is a lot tighter than this one, probably because I've just been sitting on it. But it's kind of nice, like a hammock. You kind of like could sit on top of it and you could like lean on it. Oh, this is nice. What is the process on building a reliable mechanism? For developing the mechanism, a method I like to call it is rapid prototyping. And like what I mentioned in the past, we will identify the problem, reflect on the problem, and then rebuild the mechanism. When this process is being repeated, we wanted to achieve the function before the appearance. And we want to repeat this process as many times as we can. The mechanism should perform very fast, high reliability, and strong. For the bigger robots we build, such as the FRC robot, we would play around with the mechanism for a long period of time. We would try our best to shrink the build stage and let the drivers or anybody try the robot out. We would drive the robot a lot, like through rough edges. Sometimes we would ram the robots into obstacles, people, game pieces, or even the wall. With these type of rough testing, we are able to identify the problem much faster. And then this is usually the fastest way we could test out the robot. Same method could probably apply to the MakeX robots, but probably not ram your robots into walls or people. I don't think your coach would really like it. How do you feel when you lose the competition? At the beginning, it's definitely harder because we wanted the robot to perform and we put in a lot of efforts into this robot, but it's just not stable. And sometimes it just doesn't work. And just like what Tony Stark said, part of the journey is the end. Sometimes it's not always about winning the trophies. And sometimes it's the knowledge you gain throughout the entire build season. Competition is usually 3 days, but you'll spend like half a year prototyping the robot, building the robot, fixing the robot, coding the robot. You do your research, you talk to your teammates, talk to your teachers, sharing your ideas. And I think that's what's cool about robotics. It's more about the community that makes it exciting. It's the feeling when you finally understood something, or when you have this brilliant idea that you came up 2 in the morning, you get out of bed, you have to draw it out, you have to write it down just to make sure you remember it. And that's kind of the definition for competition to me. And I really enjoy working with Charlie, Tom, Steven, Coach Shag, and all the people that I work together with. It's definitely fun times, and I definitely encourage everybody to do it. And this is kind of what I'm working with. It's a big mess. It's definitely fun going through all this stuff. A lot of tools that was left behind. Definitely gonna be fun working on this project and find the interesting things behind it. And I'm thinking about painting the walls black, having more lights in here, have more lights in here, repaint the floor. This is definitely interesting. And I can't wait. I really can't wait.